Imagine you're on a cruise with your family. There are pools, activities, and multiple restaurants. Meanwhile, a steel ball you drop in water sinks immediately, and yet the steel cruise ship, larger than a building, still floats. Clearly, something more than just a weight is going on here. So, how does this even happen? To understand this phenomenon, let's first understand how an object operates in fluids. Here we have an object fully submerged in a fluid. The fluid pushes on all surfaces of this object, and that's called pressure. Pressure is how much force is being applied per unit area. And since area is the same on all sides of the object, we could say that an increase in force directly results in an increase in pressure. Pressure not only increases with force, but also with depth. Let's say this depth is h1 and this depth is h2. The deeper an object goes, the more weight of water presses down on it. So F1, the weight of the water on the top of the object, is less than F2 at the bottom. Since buoyant force is the difference between these forces and F2 is greater than F1, the buoyant force is always positive. So if there's always a net upward force on a fluid submerged object, why don't all objects float? To find the answer to this question, let's do a little experiment. Take a piece of foil, place 2 dimes on it, roll it into a ball, and drop it into a bowl of water. It sinks. Take that same piece of foil and craft it into a boat. When you drop it into the bowl of water, it floats. So the buoyant force isn't dependent on the weight of the object, but rather how much water the object displaces. Going back to our 2 equations, we can prove this relationship mathematically. Since F in our case is the weight of the fluid, we can rewrite pressure as mg over A. Multiplying h on both the top and bottom of this equation, we get pressure equals mgh over volume. Since mass over volume equals density, we get density times g times h as our pressure. Plugging this into our second equation and doing some algebra, we get our core equation. Force buoyancy equals the density of the fluid times gravity times the volume of the fluid displaced. This shows us that an increase in the fluid displaced equals an increase in buoyancy. All in all, buoyancy is everywhere, from the floaties in a pool on a hot summer day to the marshmallows in your hot cocoa on a chilly winter evening. As you go about your day, see if you can spot it in action.